All right, so 1.4, perimeter and area in the coordinate plane. So find the perimeter and area of the figure. So perimeter is just the distance around a shape. You add up all the sides. Now, if you look at this shape, it has one side that's 15, one side that's 18, one side that's 7, one piece that's 9, and then we're missing these two pieces right here. All right? So before we can find the perimeter, we have to figure out those sides. All right? So this just requires some deducing. If you notice, again, this piece is 18. All right? And this piece is 9. If I slide this over, that's 9 of the 18. All right? So this piece is 9, which makes this 9, which makes this 9. Okay? And the same idea up here. If this is 15 across, all right, and this is 7 across, and we think about this piece being right here, well, if that's 7, whoops, hit the wrong thing. If this is 7 and the entire length is 15, that makes this 8, which makes this little piece here 8. All right? So therefore, the perimeter is going to be 15 plus 18, or 9 plus 9, plus 7, plus that 9 we just found out, and the 8 we just found out, plus the 9 we already knew. All right? So if we add those all up, okay, 7 plus 18 is 25. 25 plus 15 is 40. Just do a little mental math in my head. 9 and 9 is 18. 18 plus 8 is 26. And therefore, the perimeter is 4 plus 2 is 6. 66 centimeters. All right? Now, for area, there's 3 ways to look at this, and you got to decide what is best for your brain, how you process this. You can look at this as this box right here and this box right here. Okay? So, if we look at this box, the red one, all right, area is length times width. Area is length times width. So the length and width of this is 15 by 9. So the area of this piece is 9 times 15. So that's 135. Now remember previously we found out that this piece right here was 9. Should have done that in green, sorry. So the green box is 9 by 7. So that's 63. So the combined area is 135 plus 63. So it's going to be 8, 9, 198, and we always use square units for area. Now, that's one way to do it. Someone else might say, you know what? I see this one next to this one, side by side. And that's perfectly okay also. So if you notice, this one is 7 by 18. So the area of this tall, thin box, 7 times 8 is 56. 7 plus 5 is 126. All right? And if you remember, we found out that this was 8 before. So the area of this one is 9 times 8, which is 72. Guess what? If you add those two together, you get 198. And last but not least, again, everybody looks at things differently. There's also the idea of looking at this as a big box right here. Okay? And this box is 18 by 15. 15 by 18. All right? Which means the whole box, if you multiply 15 times 18, you get 270. Now, obviously, that's bigger than our answer, but remember, we're cutting out, in this case, this piece is missing. And if you remember, this piece right here was 8 by 9. So this piece missing is 72. So if we subtracted 72, guess what we get? 198. So my point is, there's always more than one way to do this. So you do what your brain understands and processes best. All right. So, little vocabulary. Polygons. In geometry, a figure that lies in a plane is called a plane figure. Remember that a polygon is a closed figure formed by 3 or more line segments called sides. Each side intersects exactly 2 sides, one at each vertex. The vertex is a corner. So that no 2 sides with a common vertex are collinear. Otherwise, you just have a line. You can name a polygon by listing the vertices in consecutive order. All right? So this would be polygon A, B, C, D, E. If you wanted to, you could call it C, D, E, A, B. Doesn't really matter. It's your choice. But you have the ability to name it different ways. Sorry, my pen wasn't working here. All right, here are some different names. Convex has no interior angle greater than 180. Whereas down below it, concave has at least one. So if you look here, this angle here is going to be greater than 108. I'm sorry, my bad. That is greater than 90. I don't know what I was thinking. Greater than 180 would be this right here. This angle right here. Okay? So a lot of times people like to think about it kind of like a mouth. If you think about Pac-Man, all right, kind of a mouth eating something, that's concave. Whereas convex does not have that. Okay? If you think about taking this and dropping it down towards the bottom, like a cave in, a roof falling in, that goes from convex to concave. Those are how those are related. Simple does not have self-intersecting sides. Irregular does not have congruent sides and interior angles, so it's just kind of a mess. Complex have self-intersecting sides, so when you have crossing lines. And regular has congruent sides and interior angles. So every segment on a regular one is equal, and every angle is equal. That's what makes it regular. Okay? All right. They're also classified by the number of sides. So, you know, triangle, quadrilateral, pentagon, hexagon. 7 is heptagon, 8 like an octopus, 9 is nonagon, and 10 is decagon, like decade. And anything above that, you can just call it n-gon and say, you know, how many sides it has. It has n sides. Or you can just use a number like an 11-gon or a 12-gon. All right, classify each one by the number of sides and if it's convex or concave. So let's go back. Another way of looking at that, this one is concave, is it kind of has a cave entrance because a cave kind of goes into something. So if you think about that, concave has an entrance, all right? So this one right here, if you think about it as a mouth or an entrance to a cave, that's concave. And then you got 1, 2, 3, 4 sides. So that's a quadrilateral. And we just abbreviate it with quad. This one has 1, 2, 3, 4, 5, 6. Okay. So remember, 6 is a hexagon. Some people like to think about 6 has an X in it. A nice way to remember it. So hexagon. And it is convex. And remember, if I'm going too fast, you can always hit pause. All right, find the perimeter of a triangle with vertices -2, 3. So -2, remember, this is x, then y. So x means -2 to the left, 1, 2, and up 1, 2, 3. So there's my 1 point. B, 3 to the right, 1, 2, 3, down 3, 1, 2, 3. And C, -2, this time -3. C. So find the perimeter. All right. Well, on two of these, it's easy. You just have to count. So if you count 1, 2, 3, 4, 5, 6, this piece is 6. And you count this way, 1, 2, 3, 4, 5, this is 5. So that's easy. Right there for the perimeter is 11 so far. But we have this diagonal line. That means we need to go back to what we learned on the previous lesson, which is the distance formula. So we're going to go from A to B. So remember my hint, draw this first and then fill it in, especially since we have negative numbers. All right? So just pick which one you want to start with. So I'm going to start with A. So x and x. I'm going to use -2 and 3. So -2 minus 3. And then for my y's, I'm going to use 3 and -3. And here's where this comes in handy. Because a lot of times people will just write down 3 minus 3. But it's really 3 minus a -3. And this helps you from making that mistake. Because this is going to become plus 3. So in this case, -2 minus 3, borrow $2, borrow $3 is borrowing $5. Plus 3 plus 3 is 6. And these are both still squared. So that's going to give me 25 plus 36. So 25 plus 36 is 61. Now in this case, since we need to find a measurement, we're not going to just leave it as a radical. We're going to take the square root of 61, which is approximately 7.8, and add that to the 11. So we're going to say that the perimeter is approximately 18.8. That's an approximation. All right, DEF versus 1, 3. So write 1, 1, 2, 3. 4, -3. 1, 2, 3, 4. 1, 2, 3. And -4. 1, 2, 3, 4. Down 3. 1, 2, 3. So we're going to draw here, here, and here. Well, this one's easy on the bottom. We go 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. But we need to find the distance from D to E and from F to D. So we have to do the distance formula twice here. So I'm going to do the square root. And I'm going to write down DE here to keep myself on track. So I remember to use the right numbers. Whoops. Let's put a big plus there. Put square. Put my minuses in. Okay, so D, x is 1 and 4. Y is 3 and -3. Again, that's going to become plus. So this is going to give me 1 minus 4 is -3, but we're going to square it, so it'll become positive. And then again, 3 plus 3 is 6, and we're going to square it. So that's going to give me 9 plus 36, which is the square root of 45. So we're going to put the square root of 45 in our calculators and get approximately 6.7. So this is 6.7 right here. And now we're going to do it again, but we're going to do DF. So DF. And I'm going to set up my formula like so. And now I'm going to use my points. So for D, again, it's 1 and 3. All right? So I'm just going to put those in right here. 1 and 3, because those go in the first spot. And then for F, it's -4 and -3. And that's where, again, this is going to come in really handy so you don't make that mistake. And these are both going to become plus. All right? So we end up with 1 plus 4 is 5, which is going to be squared, plus 3 plus 3, which is 6 again, which is going to be squared. So that's 25 plus 36. So 25 plus 36 is 61. And the square root of 61 is about approximately 7.8. So we're going to add 7.8. Whoops, I don't know what happened there. 7.8 plus 6.7 plus 8. That's going to give me 22.5. So the perimeter is approximately 22.5. All right, example 4. You're building a shed in your backyard. The diagram shows the 4 vertices of the shed, the corners. Each unit in the coordinate plane represents 1 foot. Find the area. So this is an easy one. We're just going to count. So the distance here is 1, 2, 3, 4, 5, 6. And this is 1, 2, 3, 4, 5. So again, length times width for area. So that's 6 times 5. So that's 30 square feet. No distance formula, we just count. And that's it.